Let's talk about AI and how we got here and the progress that AI has made today. And much of it stems from major breakthroughs in the 20th century with advancement made on autonomous machines, robotics, and computing systems. The binary computing system, which uses the systems of ones and zeros to represent data, and electronic semiconductor circuits, exponentially increased the speed and output of what computers could do, turning them from archaic machines that were mostly relegated to the imaginations of human beings to real things that could give real output in the real world. Much of this lies in the work of one British mathematician, Alan Turing, in the 1950s, which lay a crucial groundwork in determining the trajectory of the AI systems that we have today. Turing was an important asset for British intelligence during World War II, as he helped decode German secret communications. His ability to crack the codes on these encryptions would often give away German positions, providing Britain with a crucial upper hand that played a decisive factor in the victory of the Allies during World War II. And in his paper, Computing Machinery and Intelligence, that was published in 1950, Turing put forward a thought experiment, which he called the imitation game, to establish whether computers can exhibit intelligent behavior distinguishable from that of a human. The hypothesis became the basis for the Turing Test, which has been central to gauging the intelligent capabilities of AI models even to date. The Turing Test basically works on the notion of if it works like a duck, talks like a duck, then it probably is a duck. So if an AI model can exhibit thinking patterns similar to those exhibited in human intelligence, then it is probably as intelligent as a human. In this test, a human interrogator communicating remotely and within a set time limit must determine which of two respondents, a computer or a human, is the machine based solely on the answers to various questions they provide. A computer's ability to think, quote unquote, is evaluated by how often it is mistaken for the human participant across multiple trials. The approach taken by the Turing Test is also central to explaining how artificial intelligence is currently measured and perceived. It is not that these AI models exactly replicate human intelligence. They only need to imitate human intelligence enough to pass certain metrics that are widely accepted to be definitive of human intelligence. Other than the Turing Test, other evaluation metrics assess the AI model's capabilities in memory, reasoning, intuition, sensing reality, comparing these to how they manifest in human intelligence. We'll talk about this in a sec, but first, let's establish how we got here in the first place. My name is John J.B. Mungiha, and this is Officially Exaggerated, where we question the answers and take a deep and analytical look of contemporary social, economic, and political issues from the world over. Just some quick clarifications first. I am by no means an expert in artificial intelligence, machine learning, or even anything to do with computing systems, really. I just found the recent occurrence in the field of AI to be quite interesting, and I just wanted to share my findings on that. So feel free to let me know in the comments if there's something that I have missed or misrepresented in the video, and I'd love to learn and hear from you as well. Secondly, the artificial intelligence and machine learning field is wide, and there's a lot to talk about that can't possibly fit into the context of this video, which you can already see is gonna get quite long. But for today, I'll be focusing specifically on large language models and the generative AI field, since it is the most widespread and these are the most implemented across most AI applications. Our ideas around AI, that is chatbots like ChatGPT, image and video generation, software development, and automations are built mostly on generative AI technology. The period of the late 60s to the 1990s was a golden age for the development of computing technology. As the internet came into play in the 1990s, it took the power of computing to new dimensions, augmenting raw power and computing speed with cloud connectivity, which allowed for data to be stored and accessed from a centralized point. This ease of accessibility to data allows for machine training and learning in ways that could not have been possible beforehand. Fast forward to 2025, computing machines can now perform linear calculations to convincingly replicate human thought. behavior, and reasoning. Many of these advances can be attributed to the development of neural networks as well as deep and reinforcement learning, which gives these systems an ability to self-correct and iterate, which is central to demonstrating quote-unquote human-like intelligence. And as mentioned before, these computing models are adapted to replicate the thinking and reasoning patterns of the human brain. Generative AI models, for example, are built with natural language processing capabilities through which they can understand and generate from human-based language inputs. The language processing capability is pretty much the technology behind most of the large language models, brackets LLMs, that we know of and interact on a daily, like ChatGPT or Google's Gemini or Meta's Llama or Grok AI. So, how do these LLMs and chatbots really work? Let's take ChatGPT, for example. The GPT in ChatGPT stands, or is short for, a generative pre-trained transformer. Generative in the fact that it can output new data based on input given, pre-trained on a massive amount of data with a transformative ability to process relationships within the data and understand concepts and interrelations. That's a lot to swallow, but I can give you an example. Say you asked ChatGPT a question like, where is Lesotho located? The model will need to first understand the context of your question, which it does by processing various aspects of your question. Normally, a human would divide the question into sections, nouns, verbs, adverbs, etc. You would see as a human that the term where or the terms where and located ask for geographical positioning, and your mind would sift back to where you've heard or read about Lesotho before. Basically, your brain would combine elements of a sentence to gain context on the intent of the question asked before going through your memory to find the information that it's retained about the subject. ChatGPT kind of takes the same approach. However, it doesn't divide the sentence into nouns, verbs, etc., but instead, it assigns tokens to each part of the sentence. For example, it might assign where and Lesotho located to different tokens. It then runs these tokens through the massive dataset of information that it's been trained on to see how often these tokens appear together and what other tokenized information they constantly appear together with. In this case, it would arrive at the conclusion that Lesotho, located, and Africa constantly appear in the same sentence and contexts. The model can therefore predict that the answer to your question is that Lesotho is located in Africa, South Africa to be specific. Within South Africa. Okay. This is, of course, a very oversimplified version of how these models work, but it could give you, or it should give you, a rough idea of how they are built to reason. Recent advancements in the technology have led to the development of multimodal networks, which bring the generative capabilities of these models to multiple fronts. These models can now not just do text outputs, but can generate images, videos, and even code to build entire websites, all from text-based inputs. Think of DALL-E, Midjourney, Sora, etc. The emergence of multimodal models is central to the development of the so-called artificial general intelligence, which is basically AI beyond chatbots. AGI is an approach to powering computing systems that can think and act like humans. Eventually, AGI could evolve into artificial superintelligence, in which AI would act autonomously without systemic human input or control, and perhaps even surpassing us and what we perceive as our collective understanding of intelligence. But before we get ahead of ourselves with the fears of an AI that is super intelligent and has taken over, there are really bigger and more pressing problems that have to do with AI that we need to be worrying about more, especially in the moment. Now, let's go back to ChatGPT. While the model has a lot of similarities to human thought, you can see that it is also quite different. Human language is complex and is subject to a lot of nuance that we humans speak on, mostly subconsciously. Take, for example, intonation or non-verbal cues, which are central to human communications. And importantly, this nuance cannot be taught. It is already hardwired into the fabric of our thinking, and it is what makes us uniquely human. Models like ChatGPT, on the other hand, depend on deriving and predicting patterns based on pre-acquired information, as you've seen. Human brains also do the same, but they also have the ability to add nuance, which can lead to vastly different outcomes and answers from what an AI model can give given the same question. If you think about it, human intelligence is complex enough as is. It is hard to be quantified by a given set of metrics. However, artificial intelligence can also get quite complicated and quite fast when AI systems, especially these deep neural networks that some of these LLMs are built on, exhibit internal decision-making processes that are opaque and not easily understandable to humans, even though the inputs and the outputs are visible. Remember, this is a technology that is being run and maintained by humans, and we need to be constantly aware of what it is thinking behind the answers that it is giving. And the vast number of interconnected parameters and the layers make tracing these individual decisions that the AI makes to come to a decision or to give an answer difficult. Most of these models are built to prioritize performance. Hence, they need to build out complexity in these interconnected parameters. But often, this is done at the expense of transparency. Perhaps this is often more subtle and goes under the radar, or the internet discovers it and makes up memes and jokes about it. For example, remember when ChatGPT 3 could not tell how many R's are in the word strawberry? In July this year, Elon Musk announced on X that the XAI team had made improvements to the Grok AI chatbot that's embedded into the X platform. In the week that followed, and in a series of controversial posts and prompts on X, the Grok chatbot would go to refer on to itself as Mecha Hitler, praising the Nazi leader and making anti-Semitic statements in responses to user prompts and queries. It had acquired this character or this name based off a cyborg character from the 1992 video game Wolfenstein 3D. The character was meant to represent a hyperbolic sci-fi twist on the Nazi leader, Adolf Hitler, but has ended up becoming a satirical trope in internet in culture. The well-informed and well-meaning users of X, of course, jumped on this and got the chatbot to make remarks such as denying the Holocaust and also recommending a second one, and even, get this, producing violent rape narratives. XAI, the company behind the chatbot, would of course later give an explanation, stating that the behavior was as a result of depreciated code that would disproportionately prioritize extremist content that's posted on the X platform, which should come as no surprise, since the improvements that Musk had announced instructed the chatbot to, and I quote, not shy away from making claims that are politically incorrect as long as they are well substantiated, among other things. And yeah, politically incorrect and well substantiated have no business being quoted together in one sentence. Now, thinking about it, perhaps the biggest threat with AI is not necessarily with it having intelligence that surpasses and takes over humanity. They are instead bigger, more immediate, hairy problems that are evident with how the technology is developed and utilized. The development of AI seems to be prioritized on rapid scaling and improving output without first optimizing it for the human experience. And there's an even more worrisome problem. The tech billionaires, I'm looking at you, Elon Musk, and the investors behind them that are hell-bent on turning the technology into a quick cash grab without respect for the damage that the technology could cause if mishandled. That said, as we train AI on more and more datasets and increase the tokens and nodes, it kind of starts to acquire nuances and thinking patterns of its own. This can be especially damaging if it's trained on faulty data, as again, AI does not have the nuance to differentiate between faulty and usable data. It's just going to keep on deriving patterns, and as we've seen with the Grok AI chatbot and the MechaHitler incident. Hence the inherent and existential danger with AI. As we give it more and more information, good or bad, it becomes better at deriving conclusions and patterns beyond ways which we can explain, transforming the technology into a black box sealed off for us not to look into what's happening inside and get behind the scenes of its reasoning. But even so, AI still sucks at learning. A lot. It needs millions of dataset inputs for it to get close to any reasonable output results. Compare that to us humans, who probably learn a lot more with a lot less. Say you've never seen a spoon before. Then I showed you a spoon and told you what it is and what it's for. You probably wouldn't need me to show you the same spoon a million times for you to get the grasp of the concept behind what a spoon is and what it does. But guess what? With AI, you'll probably need to keep doing so, because every so often, it might just confuse that spoon for a shovel. I've mentioned before that AI models have inbuilt systems to self-iterate and self-correct. For generative models especially, this self-learning architecture is not robust enough when compared to human intelligence, at least. For many of these models, self-learning is a singular process of fine-tuning. Essentially, if the model makes a mistake, the self-correction only applies to fixing that particular mistake. Kind of a band-aid solution to correct a problem that could lie deeper in the foundational architecture that drives the reasoning patterns of the model, which is worlds different from how we humans learn and self-correct. We humans, you included hopefully, undertake in a system of continued reinforcement learning. That is, learning as we do. We don't often start off with a vast data set of information about a subject, but we learn more as we interact with it. The context that AI models need from having a huge data set of information comes naturally ingrained in us over thousands of years of continued evolution that has rewarded us with these big brains of ours. In other words, humans learn from a unique stream of multiple experiences. AI learns from millions, if not billions or trillions of disjointed data streams. This is what gives nuance to human thinking patterns, which are based on episodic experiences versus the rigid learning paths that AI models are dependent on. Think about it. Your brain could derive a lot more information from the people you interact with, your work and school experiences, and so on, than an AI model could ever acquire in its entire existence, all by just applying nuance. The problem placing a ceiling in the advancement of AI has and never was computing power or a lack of enough data for training models. Given the law of diminishing returns, we are approaching the point where the technological infrastructure does not necessarily improve AI past where it already is at the moment. We are getting at the tail end of how much scaling on more computing power is realistically possible without placing constraints on our own very limited supply of energy and resources. That said, a lot of these AI companies have been banking on a big data design model, which provides that AI can only learn with massive data sets and continued increase in computing power, which, to be honest, is fundamentally flawed and inefficient at best. After all, there's only so much information on the internet and only so much computing resource that the internet can provide given our energy resources and reserves. Why would we need to suck our planet dry for us to figure out that placing bets on AI with our resources as leverage was a bad idea? But as delusional tech billionaires would have you believe, the solution for us would be to build AI stations in space. Join me on the next episode as we unpack this whole narrative that's being peddled in the AI world and in the AI market and in the AI economy that has been driving the world crazy and that has held the economy on chokehold. We will go through and demystify all the claims that are made about what the technology can do, and we can hopefully get behind this and see what's the real truth behind what we are not being told about.